I'd like to introduce our presenter today, Archie Elston from Sapien Group. And Archie started Sapien Group while studying at university back in 2017 with a vision to make our homes more comfortable, more sustainable and less expensive to run. Archie has a background in mechanical engineering and has worked on major refurbishments of some iconic buildings, including the Arts Centre in Melbourne and Marvel Stadium. So Archie applies his engineering background and experience in home retrofit upgrades to make people's homes more comfortable and efficient, and to educate the community on how to begin the sustainable home retrofit journey. On that note, I'd like to hand over to Archie. Thank you and welcome.
Awesome. Thank you so much, Deanna. Thank you everyone for tuning in. I'll just share screen and we can get started. All right, saving energy this winter. So yeah, great introduction. Thanks, Deanna. Yeah, I started Sapien up several years ago now with a few friends of mine. We were in uni and we had our big summer holiday break that we all remember so fondly. I got knocked back from the internship that I'd applied for, and we had a bit of spare time, and we were all quite passionate about energy efficiency, being aspiring engineers, and also quite passionate about sustainability. So we put our heads together and came up with Sapien, and our first offering was draft proofing homes, which is pretty, accessible, which is great because it means you guys can have a crack as well. And I'm keen to share what we've learned over the years on how to do it really well and effectively. And then, yeah, we had a really good response, and we've been building up our business to be more holistic and make homes more energy efficient and sustainable and cheaper to run. And yeah, haven't looked back. So that's a little bit about me and how we got started. Today, we're going to talk about a few things. We're going to cover the energy efficient home retrofit journey with a bit of a slant focusing on winter as we come into winter and we want to stay warm and not spend thousands of dollars on the gas or electricity bills. We're also at the end going to go through some draft proofing DIY tips and tricks. Draft proofing is kind of the most accessible thing you can do, and so we really want to hone in on that and show you guys what we've learned. And then we'll have a Q&A at the end as well where you can ask any questions, and also feel free to post them in the chat as we go along. All right. I don't know, Deanna, can you see the pop-up that I'm getting about people entering the waiting room, or is that only on my screen? You're on mute, by the way.
Sorry, no, I can't see that.
Oh, okay. No, that's all right. I just didn't want it to be blocking my presentation for others. I've got a little bar pop up. That's all right.
Okay. All right. I'll keep monitoring.
Yeah, no stress. All right. The energy efficient home retrofit journey is made up of 8 kind of key steps. The first few steps are all about passive improvements, improving the thermal performance of the house through draft proofing, insulation, high performance windows. And then the last steps are more about the active energy users like appliances, heating and cooling, hot water, and then finally offsetting that with solar power. Typically your best bang for buck and where you want to focus your initial investments is on passive improvements, treating the problem at the source and improving the performance of the home so that it has to use less energy overall to stay warm or stay cool depending on the season. So why would we begin the energy retrofit journey? There are some really good reasons. The number one reason we get called out to look at people's places is they want to be more comfortable. So improving thermal comfort is a big benefit of making your home more energy efficient. It's also going to reduce your energy bills because a more efficient house requires less energy to keep hot or cold. And it's also going to reduce your carbon footprint, which is great given the climate crisis that we're facing. Every little bit helps. So 3 great reasons to begin the energy retrofit journey. First item on the agenda is draft proofing. I'll just touch it briefly here because we'll do a bit more of a deep dive later in the session on our DIY tips and tricks. But really, this is kind of the first step in the journey. It's kind of one of the cheapest things you can do and the most accessible things that you can do, and the benefits can be huge. Air leakage can account for 15 to 25% of winter heat loss in Aussie homes. So 25% reduction in heating, it can be pretty good. When we draft proof homes, often it improves acoustic separation. We've had a few jobs that face, a sports oval or a busy road. And once you've applied some draft proofing, you can really notice a marked difference from the noise ingress. It's also going to reduce ingress of dust and bugs, which is a big plus, improve the air quality a little bit. Now, if you want to find the worst sources of air leakage in your home, typically what we would do, we've got a blower door, it's got a big fan and it sucks air out of the house and depressurizes it, and we can go around and feel where that air is coming in, where it's being made up from outside. You can do something similar if you just go around to all of the extraction points in your home. So switch on the kitchen exhaust hood, the bathroom exhaust fans, and then shut all the doors and windows. Often that's enough to even just feel where the air is coming in through different cracks. And you might want to shut all the bedroom doors and stuff to kind of, so the fans are pulling less volume, if that makes sense, and go through them one by one. But yeah, I think it's a fun exercise if you're a draft proofing nerd like me. It's like a bit of a treasure hunt, and you can go around the house and actually feel where it's coming in. So just switching on all of the extractor fans in the house and then feeling where that air is pulling in around windows and doors and stuff. And we'll go over like some typical things to look for later on in the session. So next item on the list is lighting. So halogen downlights, off the bat, they use more electrical energy than LEDs. So it's always a good idea to replace them. They also are typically ventilated because of the heat that they generate. And this ventilation is an unwanted source of air leakage between the roof or ceiling cavity and the conditioned space. The roof or the ceiling cavity can get quite hot or quite cold depending on the season. So we really want to avoid that. And the third reason that halogen downlights can be quite problematic is they have clearance requirements where they need to be free from combustible materials like insulation, because they generate so much heat. And that's actually the reason why they're kind of so early in our home energy retrofit journey, because they have run-on implications for other things like insulation. So if you have halogen downlights, you can't get good insulation coverage. You can see I've got a thermal imaging shot from one of our houses in that image in the center there. And you can see there's just a whole insulation bat missing where that downlight is sitting. And this is a really big problem because a loss in insulation coverage disproportionately affects the performance of the insulation. So a 10% drop in insulation coverage is more like a 30 to 50% drop in performance. So 30 to 50% more heat being lost, depending on which studies you look at. So we really want to replace our halogen downlights so that we can insulate properly. And it's important that we replace the whole fitting with sealed LED fittings. Changing the globe is good because you're going to use less energy, but we still have a ventilated fitting and we still can't insulate right up around it, even though it's generating less heat. The globe could blow 5 years from now and someone could put a halogen downlight back in. So we need to replace it with a fully sealed LED fitting, then we can insulate right up on top. So insulation, and this is a huge one in winter. So you can see in the image there, we're losing 25 to 35% of our heat through the ceiling during winter. And as we discussed, a loss of coverage in insulation has a disproportionate effect on its performance. So it's really important to get really good insulation coverage, especially for the ceiling, which is where we're going to lose most of our heat during winter. So we recommend R5 bats for ceilings. R is a value of heat transfer resistance. So it's resisting the passage of heat in one direction or the other. R5 is a little bit above kind of code compliance levels. You can go higher than R5. It certainly doesn't hurt, but you do start to get diminishing returns with the more insulation you add. And R5 is a really good sweet spot for maximizing the performance of the insulation and holding the heat in without kind of going overboard and not really seeing the returns. For walls, which often lack insulation, there are options available in the market for blow-in wall insulation, where they'll cut like a 50-cent sized hole or several of these holes through. They can do weatherboard, brick, or plaster from the inside and blow insulation into the walls to fill them up. And that's a really good solution for retrofitting the walls with good quality insulation. A little trick to see if you actually have wall insulation, you can pull the cover off a power outlet and have a little look. Obviously be very careful of any wires and that kind of thing, but if there's no insulation packed around that power outlet, it's unlikely that you've got good insulation coverage in the walls. Then for underfloor, we recommend R2.5 polyester rolls. These are just a really good product, and you can staple gun it into the joists and it's really snug. And you're not going to have any kind of gaps and stuff for vermin or that degrade the insulation coverage. There are a few other solutions. You see people kind of strapping in bats or kind of trying to hold them in with chicken wire. And generally they're not a super robust solution, whereas the polyester rolls are nice and robust. And you can even install them yourself if you want. There's plenty of videos on how to do it, and you can order the rolls, or you can get someone in. You usually need about 400 mil clear under the house to be able to install it. Were there any questions yet?
Yeah, we've got one question, Archie.
Yeah.
Coming from Alex in relation to the halogen. So how do I know if the downlight is a halogen or LED?
Great question. So halogen downlights will always have a little globe in it because they've got a filament that heats up and generates that light as a result of that process. And LEDs typically have, they kind of just look like little orange squares. They're like little chips almost. And so, yeah, that's a way to tell. They look visually different. And if you jump on Google Image and just have a look at halogen versus LED, you'll be able to see some comparisons. But yeah, if there's a globe in the downlight, typically that's going to be your halogen fitting. Whereas yeah, if you've got like 4 little orange squares, like little chips, then that's going to be an LED.
Okay, great. Thanks, Archie. Another question from Nancy. What options to underfloor if clearance is too low?
Yeah, unfortunately, not a lot. If there isn't enough clearance to install anything, you might have run into a little bit of trouble. You can look at treating it inside the house. If it's floorboards, could look at getting carpet overlay, which will add extra heat resistance. But yeah, unfortunately, if you can't really get under the house to install insulation, it does limit your options. So maybe you want to focus on the ceiling and the walls and getting them as good as you can. And you may have to park getting quality underfloor insulation installed if there's not enough clearance. And that's just the reality of the retrofit process when you're dealing with existing buildings. Sometimes we can't get everything to work.
And a question from A, who says, if I have floorboards that have gaps that are letting in draft, how would polyester rolls work? Or would there need to be another solution?
Great question. Both. So the polyester rolls will be good, and they would definitely restrict airflow to a high degree. If you think about the path that the air has to follow with just a gap in the floorboard where the air is directly exposed to it and it can come up, compared to having a polyester roll that's like 300 or 400 mil thick and the air has got a much more tortured path to try to get through. It would also recommend draft proofing the floorboards with like a wood colored gap filler and the caulking gun, something like this. This is just a white colored one, but you can get different wood colored caulk. And I would go in between the floorboards to seal them up, as well as insulating underneath. So good question.
Sorry, Archie, are you showing that on the screen?
Oh, on the camera. I don't know. Can you?
No, we can't see because your presentation is.
Oh, I'll stop sharing for 1 second. Can you see my camera?
Yep.
I've got the caulking gun.
Okay.
Yeah. So yeah, caulking gun, and you can get a gap filler that's like a wood colored gap filler, and use that to go in between the floorboards. So yep, good question.
Okay, no more questions at this stage.
Awesome. All right, well, we'll charge on ahead. All right, so windows, what can we do about windows? Plenty of heat is lost through windows, and once we've draft proofed the house and put in good quality insulation, this is typically going to be our next kind of largest source of winter heat loss. A couple of behavioral things we can do off the bat, so really easily accessible, is have all the blinds open during the day when the winter sun is coming in to heat the home up, and then shut them at night so that we can retain more of the heating from any heating system that we're running and lose less of that heat to outside. There are different types of blinds and curtains, and some are better than others. You certainly want ones that are going to take up the whole kind of window frame space so that they're holding like an air gap in there. And you can also get blinds. They're like, they're called like honeycomb blinds. And you can see I've got them pictured there in the center image. And when they drop down, they actually form like a three-dimensional honeycomb shape. And so they've got a really good insulation property as well. So that when they're closed, they really hold the heat in. So definitely something that's worth considering. Another option is secondary glazing. So this is obviously double glazing is great, but often if you do have a lot of single glazing, replacing it with double glazing can introduce budget concerns. It is quite a high cost item. A bit of a lower cost alternative that can get similar to the same results is secondary glazing. So it's kind of like a magnetic spacer that goes around the window frame and then an acrylic pane that goes over the top. And so you're getting that extra thermal resistance like a double glazing unit would at a lower price point, and without having to replace the window frame as well. So arguably more sustainable. So that's something to keep in mind. Also, if you are looking at replacing windows, something to keep in mind is the window frame. So you really want either thermally broken window frames or window frames made out of a material that doesn't conduct heat very well, like wood or plastic. If you do want a metal finish, it's important that it's thermally broken so that in between the inside and the outside, you've got something that's going to resist that heat transfer. Otherwise, the frame becomes a weak point in the glazing unit and you'll get a lot of heat transfer through a solid metal frame. There are also some window films out available on the market, some just like a sticky film you can apply to your window. The cost benefit with these is somewhat dubious, and it's important to do your research when you're looking at products. So something like a low emissivity film, it will reduce the amount of heat that your windows lose during winter, but they're also quite reflective. And so you're going to reduce the amount of sunlight that comes in and warms the home. So the benefit is kind of dubious. In summer, they're great because they're reflecting the sunlight and preventing it from coming into the home. But in winter, the benefit's less apparent. So it's just important to consider window films holistically and make sure you do your research in getting a product that's going to work. But yeah, oftentimes the benefit of window films is kind of dubious if you're considering a year-round approach. Then shading. So really good one is having deciduous plants. Deciduous plants are plants that will shed all of their leaves in winter, so we can let that sun in and warm up the home. And then they're going to be nice and leafy during the summer to provide some shading. For our north-facing windows, we've got a really good opportunity to have intelligently designed fixed horizontal shading with things like eaves. When they're designed correctly, you can block out that summer sun, which is high in the sky, while still letting in that direct sunlight from the winter sun when the sun is a bit lower in the sky and warming the house up, just like that image I've got in the bottom right there. And similarly, you can do this with louvers if they're designed correctly with the spacing and the angle. You can let in that winter sun while preventing that summer sun from coming in, like that image in the middle there. For east and west facing windows, because you've got the sun starting low in the sky and going high, you need adjustable shading if you want to make it work. So you can let the sunlight in when you would like it in winter and block it when you wouldn't. All right, I might just do this slide, then we'll stop for questions again. Appliances and cooking. So these account for about 33% of energy consumption in the average household. So a reasonably big ticket item. When you're due to retire an old appliance, it's a great idea to replace it with a high efficiency alternative. They basically all have the star ratings on them now, and you can use that to help guide your decision. Another thing to consider is choosing appliances that are the right size for you. So take a fridge, for example. Often a smaller fridge with a lower energy efficiency star rating is still going to consume less energy than a larger fridge with a really high efficiency rating. So just having appliances that are sized correctly for your needs is often one of the best things you can do to reduce your energy use. So something to keep in mind. Some behavioral things like avoiding part loads in the washing machine or the dishwasher, so you're getting your bang for your buck when you run it. Turning off appliances when we're not using them, preferably at the power point. And there are also a number of different standby control devices available in the market now to prevent that standby power being drawn by your devices when they're off. Consider retiring older, less efficient appliances instead of retaining them. The classic Aussie example is the old fridge that's ready to be replaced with a nice shiny one, and we put it in the garage and use it as a bar fridge. Great utility, but not great for energy use. And if you can bear to part with it, it's probably a good idea to get rid of it altogether, as these old, less efficient appliances can be a real drag on our energy usage. If you're looking to upgrade or replace your stovetop, consider going with an induction cooktop. They're by far the most efficient option. And we'll discuss kind of gas versus electricity in a minute as well. Now, are there any questions along the way?
Yeah, we've got a couple, I think. All right, from Rodney. Rodney asks, is it worth double insulating the roof cavity? Sorry, I don't quite understand the question. It says, do PowerPoint allow cool air in? So part one of that is it worth double insulating the roof cavity?
When you say double insulating, more insulation never hurts. So the better insulated the home is, the more stable the temperature is going to be and the more you can control it. In terms of cost benefit analysis, there is kind of a bit of a tipping point, which is where you hit that R5 value. So depending on what kind of insulation you're using, double insulating it may be overkill, in terms of a life cycle cost analysis. But in terms of just comfort and operational cost, it's always going to be good. It's certainly not going to do any harm, but yeah, at about R5 value insulation, anything above that, you do start to get diminishing returns on putting in extra insulation. So that kind of answers that question.
Yep. And sorry, with that second part of that question, I think Rodney's asking if PowerPoints, like wall PowerPoints, do they allow the cool air in?
They do, yeah. They're a source of air leakage. So if you're not using a PowerPoint, it's just 3 holes straight into the wall space. We don't want air exchange between our wall cavities and our condition spaces. So ones that you never use, we recommend getting just the little, I'll switch off my screen for a second so you all can see me. We just recommend getting the little child safety outlet covers, and you can just plug them in. Power outlets aren't going to be the worst source of air leakage in your home, but it's such an easy fix. We always recommend just going around and plugging up the ones you don't use, because yeah, you're spot on that when you're not using them, there is air exchange, and you'll be able to feel it potentially if you go around and switch on all of the extractor fans, like we said, put your hand in front of a power outlet, and often you can feel air pouring in. So it's a good one.
And Chris is asking for double brick cavity walls, if blowing in insulation, is there a risk the insulation getting wet via water migrating via the exterior masonry skin?
Right, okay. My understanding is with the supplier we use for blown wall insulation, they can do it with double brick cavities. I'm not sure on the details and the theory on moisture management, but my understanding was that it is a solution that is applicable for that application.
Okay, all right, I think that's it for now. Thank you.
Awesome. All right, so a quick note on gas. This part is a little bit dense, but just stay with me, and I think it is valuable information. So a home that uses mains gas can never be zero emission. Inherently using gas, it's a combustible fuel source, and that generates greenhouse gases. Also, predictions are showing that the greenhouse gas emission factor from electricity generation in Victoria is expected to continue reducing as we add more renewable energy sources to our grid in Victoria. So electricity is becoming more and more sustainable, and there are also renewable sources we can purchase our electricity from. There are various suppliers. I think I use PowerShop, which either use renewable sources or offset the emissions. You can also offset any electrical energy with rooftop solar. So just something to think about in terms of the full home energy retrofit journey is we kind of encourage people to start moving away from gas. There have been a few studies around this. So in 2018, there was a study by Renew looking at the cost differences between gas and electric appliances. Now, it found that if you only have one gas appliance in the home, then it's always more cost effective to replace it when it's due for replacement with an efficient electric alternative. This is because, one, there are some efficient electric alternatives for gas appliances, and two, if it's your last gas appliance, you're also getting rid of the fixed connection fee by getting off gas altogether. So the finances really make sense in that case. Then if you have more than one gas appliance, so you've got a few different gas appliances, it's more cost effective to replace a gas heater with a reverse cycle air conditioner when it fails. If a hot water system fails, it's more cost effective to replace it with another gas one, unless you're planning on going to an all electric home. So it's always more cost effective to replace gas heating with an efficient reverse cycle air conditioning system, life cycle cost analysis. I think they did it over about 10 years or so. But the hot water, not so much, unless it's your last appliance, and then it will be cost effective. Hopefully that's making sense. They also had a follow-up study looking at it from an emissions perspective. So replacing a ducted gas heating system with a reverse cycle air conditioner reduced greenhouse gas emissions. Replacing a gas hot water system or gas stovetop with an electric heat pump or electric stovetop actually marginally increased greenhouse gas emissions. Now, again, it's important to consider here that our electricity grid is becoming more sustainable. And there is a lot of discussion around the accuracy of greenhouse gas emission factors for natural gas, because there are some things that people argue aren't considered into that figure, like leakage and some transport. So generally, we still push people towards the efficient electric alternatives, but on a statewide electricity generation level, it actually does create more emissions to replace gas, hot water, or gas stovetop with an electric alternative. Replacing a gas hot water system or gas stovetop with an electric alternative in conjunction with switching to reverse cycle air conditioning resulted in significant emission savings. So the switching to reverse cycle air conditioning for heating outweighed any marginal increase in emissions that came from switching to electric heat pump hot water or an electric stovetop. A lot to take in there. If you have any questions, I might go a couple more slides deep and then we can address them, but some interesting information. All right, heating. So heating and cooling accounts for approximately 40% of household energy use. So this is our biggest energy user. There are kind of two main systems. We've got central heating systems and space heating systems. Typically, so a central heating system is like, your central ducted system that ducts to every room and heats up the whole house, whereas space heating might be a split system on the wall that just heats that particular space. Typically, space heating systems will use less energy because the house is better zoned, so you only need to heat the spaces that you're using. And using central systems also introduces a number of additional potential losses, like air leakage through ducted systems, also heat losses through the ducts themselves. So all of the ducts passing through the roof space or under the floor is a ton of surface area, which is an opportunity for heat to leave the house. And we've also got additional fan energy because the fan has to work to push the heated air to all of the different rooms. So typically our space heating options are more efficient than our central heating options. Touch on a few different common types like wood heaters, reverse cycle systems, gas systems, and conventional electric heaters. So conventional electric heaters can use up to 5 times more energy than a high efficiency reverse cycle air conditioning system. So typically we encourage people to move away from conventional electric heaters. They're usually the least efficient option, although if you're renting and you don't have heating, they can be cheap to buy a little portable electric heater. And using an electric heater to heat up one room could still be using less energy than a central system doing a whole home. So, but yeah, typically we do try to move away from these electric options. All right, so wood heaters. Wood can be a great renewable fuel source if it's harvested sustainably. There are a few different types of wood heaters. Open fireplaces are the most inefficient. Most of the heat is lost straight up the chimney, and they get through a lot of wood. A better option is the airtight, slow combustion heaters. They're a lot more efficient and cost a lot less to run, just like the image in the top right there. If you do have an open fireplace, you can get inserts to make them more efficient or upgrade them. There are two main options. You've got your steel framed open fire, which is a bit better than an open fireplace because you get a bit of additional conduction from air heating up around the steel frame and moving into the room rather than an open fireplace, which is primarily just radiant heat. But we would recommend going with an insert that turns your open fireplace again into a slow combustion heater, which is the most efficient option. Something to consider though with fireplaces, especially in urban areas like Melbourne, is they are a source of local air pollution. So we tend to push people towards other alternatives if they have them, like the gas ducted or splitties. Fireplaces are quite nice. They feel good to sit around the fireplace, but they aren't great for the people in the surrounding area. And also, while wood can be a renewable fuel source, we also need to consider transport emissions. So where we live, there may be quite a road from where that wood is harvested to where it's transported to, and there are additional emissions to consider there. All right, so we've also got ducted gas heating. So again, we've got the issues inherent with ducted systems. And you can see there, I've got some images from a job that we did. And when you take the vent off the ducted gas system, you can see all of the gaps around that duct in the bottom right image. They go straight down to below the house to the dirt. And there's tons of air leakage through those. And I see it in every house that has underfloor ducted heating system. There's always these gaps. And again, this is a good opportunity to get the caulking gun out and just caulk around that duct and then put the cover back on, and you've sealed it up nicely. So these are typically less energy efficient when compared to high efficiency reverse cycle air conditioning alternatives like we discussed in our note on gas. All right, so reverse cycle air conditioning, the premium, also known as air source heat pumps. It's the same thing. You can use those terms interchangeably. All right, one cool thing to consider if you're getting a new one is where to locate the outdoor unit. So all reverse cycle air conditioners have an outdoor unit. And if you can put it in a location where in summer it is shaded so that it can effectively reject heat from the home, but in winter it actually gets sun on it to help warm it up, and then it's going to pull heat from outside and pump it inside, hence a heat pump, then that can be a cool way to get more performance out of your reverse cycle air conditioner. And it's a good opportunity for deciduous plants again, or well-designed shading if you can put the outdoor unit on a north-facing part of the home. There are a few different types of heat pumps. There's individual split systems, which is pretty common. So you get one outdoor unit and one indoor unit. These are generally a higher efficiency than our central systems, as we discussed, as every space is individually controlled. There are also multi-head splits, so you can have multiple indoor units, so in a few rooms, connected to a single outdoor unit. These are more cost and space efficient than our individual split systems, which have an outdoor unit for every indoor unit, but they are typically a little bit less energy efficient. So something you can consider there, the upfront cost will be less, but your running costs will be a little higher. And then there's the ducted systems, which are not a bad option, but again, does introduce all of the additional risks and inefficiencies that come with a ducted system. And it is typically less energy efficient when we compare it to our individual splits. Also, if you've got a portable heater, which is quite common, especially if you're renting, heater placement can really affect your comfort and getting the most out of that heater. So when you've got a heater and it's producing warm air, when that warm air comes into contact with cold surfaces or other air leakage, like around a door, then the air is going to cool down and that cold air is going to be drawn back towards the heater as the hot and cold air mixes. So if you don't want to create a cross draft that you're going to feel, you can arrange the furniture and the heater to minimize sitting between the heater and other cold surfaces. So you can see the two images there. On the left, the heater is in the corner and the sitting area is between the heater and a cold surface. In this case, is the door. And so that cross draft is passing right across where people are sitting. In the image on the right, they've moved the heater. You still get that cross draft. That's just physics. But now you're not in the line of fire. You're sitting off to the side, enjoying the warmth without that cold draft being generated and affecting your comfort. Okay, that was my piece on heating. Do we have any questions?
Yeah, we've got a few. All right. Just going back to insulation, Rodney just asks, is it worth, well, he said that he's read that house slabs can keep the house colder, and he's asking, is it worth insulating the slab edges? And if so, with what?
Yeah, it's definitely worth insulating the slab edges. If you can uncouple the slab from the soil, which typically sits around kind of a constant temperature of about 16 to 18 degrees, then yeah, insulating the slab edges is a good idea. In terms of products, I think a common one is kind of polyester or polystyrene products, which have a pretty good insulation value. But yeah, might be worth doing a bit of a search for what else is out there. But yeah, I think it's definitely worthwhile to insulate slab edges.
And Alex just made a comment saying that if you have solar, replacing gas hot water uses much less emissions.
Exactly right, because we can switch to an electric alternative. Yep.
Yep. Okay, then we've got another person
I'll just do one more because I'm conscious of time.
Sure, yeah, sure. Is there a recommended panel heater which offers good value and heating? And if so, what size per room? What is the calculation per square meter?
Oh, that's a very specific question. I don't have the answers to that off the top of my head. If you are looking at panel heaters, I would suggest looking at some kind of hydronic system that does use a heat pump to heat the water that gets pumped through the panels rather than an electric panel, because remembering that our kind of conventional electric systems are very inefficient. So I would be looking at those alternatives if that's the way you want to go. In terms of specifics of sizing, I'm not sure off the top of my head. Would have to do a bit of research to get back to you on that one.
Right. Well, there's another couple of questions, but we can leave those.
Yeah, all good. I might keep charging along.
Yep.
All right. Hot water accounts for about 21% of household energy use, so pretty big ticket item. Behavior change here can be a great saver. So having shorter showers is probably the biggest one, and cold water cycles on washing machines and dishwashers can also reduce our hot water consumption by a fair bit. Again, we've got a few options: the heat pump versus gas versus electric element. I don't even think you're allowed to install new electric element systems anymore, but if you do have an existing one, it's probably worth thinking about retiring it because they are incredibly inefficient compared to gas or an electric heat pump. And heat pump versus gas, we did talk about in our note on gas. So if the hot water system is your last gas appliance, it's more cost effective to replace it with a heat pump alternative when it's due for replacement. And depending on where you get your electricity from, it may be a little bit less sustainable to use an electric heat pump. But if you have solar or if you are buying from a green energy retailer, then the heat pump generally comes out on top. And that's typically what we recommend. Solar hot water. So in Melbourne, we can get good solar hot water. The only thing to consider here is often we do have limited real estate on the roof where we're getting good sunshine, And potentially the space where you would put a solar hot water system may be better served by putting down some solar panels. And then that solar energy can be used not only to help power a hot water system, but also to power and offset energy use across the whole home. So something to consider there, which leads us on to solar power. So price of solar has been dropping steadily for years, becoming much more financially viable. At the moment, the payback period seems to sit around 5 years for a 5 kilowatt system in a typical Melbourne home. And if we followed the other 7 steps of the home energy retrofit journey up to this point, a 5 kilowatt system can actually potentially offset the total energy consumption of the home, effectively making it energy neutral or even energy positive, generating more electricity than it consumes. So applying all of the other steps leading up to this point can make a huge difference. All right, up to my favorite bit, draft proofing tips and tricks. So I wanted to run through a bunch of different things that we can look out for and how we can solve them. And all of this stuff is stuff that you guys can go and get materials from Bunnings or online and get started straight away. So classic one is doors. For the bottom of the door, you can see I got 2 images there, one kind of in the top right and one in the bottom left. What we've got there is a hinged door seal. So when the door is open, the hinge sits up and the door can swing freely. And then when the door goes to close, there is a cam, which is this little nub that's screwed into the door frame, and that hits the hinged door seal, and then it closes, forming a seal on the sill there. So that's typically what we go for with hinged doors. If you're looking at sealing around the door frame, there are a bunch of different products available, and some are definitely better than others. I may stop sharing my screen for a second so you guys can see my camera. So the sort of lowest cost option for sealing around the perimeter of the door, which is often where there is a bunch of air leakage, is these kind of foam seals that you put around. We tend to steer away from these. You can see even this one has started to become discolored, but they degrade quite quickly and they become discolored in sunlight. But yeah, these kind of, they work, but you'd have to replace them quite regularly, and they do degrade quite quickly. So not a very robust solution. We typically steer clear of these foam-based seals. A step up from that is you've got these rubber seals. These are just from Bunnings, different types for different sizes. Not a bad solution. The only issue we run into with these is often with a door, the gap is uneven. So you might have a really small gap down the bottom and a really big gap up the top. And then these kind of stop being so effective. Often they're only sealing part of the door or even stopping the door from closing properly. So you can run into issues with these, but where they do work, it's not a bad solution. What we tend to go with, and what is a good option instead of that, is a roll of this stuff. It's a plastic folding seal. The way this stuff works, and you can't get this from Bunnings, this is online, you can get it from Efficiency Matrix, and happy to share around some links after the presentation. But basically, if you cut a bit off, it looks like this, and it's got an adhesive backing on one side. And when I put the presentation back on, you'll be able to see I've got some photos of it installed. But basically, if you can imagine, this gets stuck around the door frame, and as the door closes, it hits that seal, and no matter what size that gap is, anywhere from kind of 2 to 8 mil, the folding seal will just adjust to form a nice air barrier. So typically we have a lot more success with this stuff than with the other 2 Bunning products that I just mentioned. It's a lot more flexible, it's quite robust, it lasts a long time. I've got it in my house and mom and dad's, and it's been there for a couple of years, I think, and haven't had to replace it. So definitely a good product. There is even kind of one more step you can go. It's a bit more expensive, but you can get these seals from Efficiency Matrix. And again, I got an image of it installed that I'll show you in a second. But basically, it's got an adhesive backing here, and it sticks around the door frame on the outside. And when the door closes, it presses against this rubber seal. These are very robust and pretty much work no matter how big the gap is. It's typically what we would install on a regular job. And yeah, definitely recommend it, but it is at a higher price point. They're quite expensive, these kits. Certainly the folding seal is a great way to get started. It's like $50 a roll. And you can do doors and casement windows, awning windows. But if you want to go a step further, this is a good solution. And I'll switch the presentation back on for a second so you can see what I'm talking about. So in the top left image, you can see I've got that folding seal installed in the frame there. So when the door closes, it just rests against that, forming a seal. And in this top right image here, this is a photo from outside, and you can see I've installed the one that I was just showing you. They're from EcoMaster. And yeah, it's quite a neat aesthetic solution that works really well, but that's what it looks like when it's installed there. While I'm on this page, let's talk about evaporative cooling vents. Evaporative cooling vents are a big source of air leakage. When they are operating, they bring in air from outside. When they're not operating, they're supposed to be sealed off, but they never seal 100%. There's always tons of air leakage. And if you've got them, you'll feel it when you switch all your extractor fans on. There is a really good solution though, fortunately. So you can see in the top left two images, there is a collar that has been stuck around the outside of the vent. And then there's a plastic cover that just magnets on. So you can just click it on when you're not using it. And then when you want to use it during summer, you can pull it off. But during the winter months, when you're not going to use the evaporative cooling, you don't want a ton of air leakage coming in through the evaporative cooling vents. Another one while we're on this page is permanent wall vents. So these are kind of left over from the days of open flue gas heaters or kerosene heaters or open fireplaces, where there was that risk of potential asphyxiation from the combustion reaction burning up all of the oxygen in the space. If you don't have any of these systems now and you have a more modern heating system, then generally these are safe to seal up. And we just use a plaster compound and fill it up and scrape it smooth. If you want as well, there are products from Bunnings, which are quite simple. I'll jump back to the camera. But something that's a little bit simpler is you can get these wall vent covers from Bunnings, and basically they just look like this. And they've got a couple of little pegs which go into the slot and a couple of adhesive strips. These aren't a bad solution. They're not as airtight as filling the wall vent up with a plaster compound. I don't know why, but they don't have an adhesive strip on the top and bottom. It seems like a design flaw to me, but it's certainly better than nothing, and it's going to restrict air leakage through those wall vents. The other one while I'm on the camera is fireplaces. So if you have a fireplace that you don't use, or if you have a fireplace at all, typically that's places are a couple different solutions. So one of them is chimneys. Not a bad solution. We have run into issues where they can leak a little bit or deflate over time, especially if you put it on a warm day and then it cools down and air shrinks a little bit, the balloon, and sometimes need topping up. So it's not a terrible solution. It definitely works, but we've kind of moved on from this to different products now that are a bit more robust. That we did start out with the chimney balloons. Now for a fireplace, we would use some medium density rubber foam. So this stuff's great. You can get the kits from EcoMaster, or you can buy medium density rubber foam direct from Clark Rubber, which is cheaper. And basically you just cut this to a size slightly larger than the throat of the chimney, and then you push it up there, and then that stops the air leakage. So nice and robust, they don't fall out. So we think this is definitely a better solution than the chimney balloons, a bit more robust. All right, what else have we got? I'll share screens again. Skirting. Lots of houses have a ton of air leakage around the skirting. Again, for this, just get the trusty caulking gun out and some kind of acrylic caulk gap filler. You can just run all around the skirting and then follow it on with a damp cloth to clean it up as you go. can result in a lot of air leakage when you think about the skirting throughout a whole house. Ducted heating vents we talked about when we were looking at gas ducted heating. So often there's a bunch of air leakage around those heating vents. And again, getting the caulking gun out is a great solution. Floorboards we also touched on. So some kind of wood colored gap filler is often a great way to go. Again, unused power outlets. If you've got, you can get child safety protective covers just from Bunnings and plug them up to seal them. Extractor fans. Extractor fans is a good one. So if you think about an extractor fan when you're not using it, it's basically just a gaping hole into the ceiling. So we don't want that. We don't want air leakage between the roof space and the condition space. So what we can do is get something like this. This is a draft stopper for an extractor fan. And these go in the ceiling over the top of the fan. And then when it's running, the airflow lifts the flaps up and it can operate normally. And when it's not, they fall back down, forming a bit of a seal. These aren't perfectly airtight, but it's certainly a step up from having a gaping hole in the ceiling with the extractor fan. So good little solution. The only issue you might run into with these is occasionally, if it's a really old fan that doesn't have a lot of power, it can't even lift those two flaps up, but usually it's fine to pop those over the top. And there's only a few minutes left, so maybe I'll stop there for a second and address any more questions that have come through. But hopefully that gives you a lot of food for thought about all the different things you can do. Bit of an information overload, but I believe the session's recorded, so you can go back and have a look at these different tips and tricks.
Definitely is recorded. Okay, so Rodney asks or says that he's put pot plant containers over the top of the LED lights in the roof and then insulation over the top of that. Is this okay or dangerous?
It'd probably check with the supplier of the LED lights. My gut feel is that it would be fine. If it's an IC4 rated LED fitting, that means you can insulate right up on top of them and they're not going to be a fire hazard because that's how they're rated and how they're built. But yeah, definitely don't take my gut feel for it. Get in contact with the supplier and ask them if it's safe to cover it with a pot plant like that. But yeah, I think you'd be pretty right. The LEDs don't generate a lot of heat. That's the whole point. So yeah, get in touch with the supplier to confirm though, because never know. It can't be too safe.
Okay, thanks, Aki. And there's one other question. Miguel is asking how to find the right size in kilowatts for reverse cycle unit, for a reverse cycle unit in a lounge room with dimensions. Well, they're specific dimensions. They're 10 meters by 4 meters. But more generically for other people who have dialed in, where can they get that information?
Yeah, I don't have a kilowatts per square meter off the top of my head, but I'm sure it's only a quick Google search away, or even ringing up a supplier and installer of the reverse cycle units. Certainly, if you follow the other steps with passive improvement, often you don't need a system to be as large, or if you do get a large one, it won't have to work as hard. But yeah, I don't have a specific number for you off the top of my head, unfortunately, for specific dimensions, but I don't think that information is too hard to come by. And certainly suppliers would be more than happy to oblige a question like that.
Thanks, Aki. Yep, no further questions at this stage. So if you've got more to cover off, we've got couple of minutes left or so, thereabouts.
Brilliant. Okay. What else have I got? Oh, the other one is plumbing fittings. I'm not sharing, am I? So I've got an image there, kind of at the bottom there. You can see a lot of air leakage coming in around that plumbing fitting. This is super common. Often there are lots of gaps behind cabinetry. So any holes in the cabinetry leak a lot of air. And for those, again, we'll get the trusty caulking gun out, or where the gap is too large, we can also stuff it with some gap filler rod. I'll switch back to my camera for a moment. So gap filler rod you can get in a box like this from Bunnings. They come in a few different sizes. They got the little one. This is more of a medium one. So you can just pack that in and around the plumbing fittings and finish off any smaller gaps with the caulking gun, and job done. You can walk away. They don't need to look particularly pretty because nobody's going to see them. What else? Doors, windows. Oh, we didn't talk too much about windows. So again, we can use our folding seal for a number of windows, like awning windows. With sash windows, because it's a sliding application, we need to think about something a little bit different. You can use this in between the stationary pane and the sliding pane, just to seal between those two pieces. But around the frames, there is a good little solution. Again, these are from EcoMaster, and it's a brush seal that sits around the frame and along the bottom. And so when that sash window is running, it's just sliding up and down along this brush. I mean, brushes typically aren't perfectly airtight, but if you've got a rattly old leaky sash window, it's going to be a marked improvement and really restrict the amount of air that's coming in around it. So that's a good little solution. Again, these are a bit expensive. You can always have a play just with some classic brush seal from Bunnings. This stuff's pretty robust as well. It just comes in a little packet like this, and it's got adhesive strip on the back, brushes on the front. You can use these on sliding doors, sliding windows, sash windows, wherever you can get them to fit. For sash windows, these are typically, we have a bit more success with them because they sit on the outside of the frame and push against the sash window. They can work sort of regardless of the size of the gap, where sometimes these aren't perfectly suited to the size of the gap. But you can have a play around, but there are a couple of different products that are well suited to kind of sliding applications where you really want to brush rather than a rigid seal like a plastic seal or a rubber one. And I think we're just a couple minutes over. Were there any other questions coming in?
No, doesn't look like it. Just lots of good comments and feedback for you, Archie,
oh, great.
which I can send to you later.
Yeah, brilliant. Oh, someone's got the
yes, there is
the
one.
heat save event covers.
Yes. Oh, yeah. I missed that one. Sorry.
Yeah. No, that's all right. Yeah, that's good. That's what we use. So yeah, I've got one here. But that's the image I was showing you where these just magnet on. And there's honestly a ton of air leakage coming through evaporative air conditioning vents when they're not being used. So highly recommend the heat save event covers. Really good solution.
Fantastic. Myra's just slipped in a quick one where she's asking about a magnetic spacer.
For the secondary glazing. Yeah. So yeah, for the secondary glazing, EcoMaster does secondary glazing with the magnetic spacers. There are a couple of other suppliers. I don't know them off the top of my head. But yeah, if you do a Google search of secondary glazing or secondary acrylic glazing, should come up with a list of suppliers. But yeah, EcoMaster is the one that I know off the top of my head that does do it.
Fantastic. All right. Well, on that note, Archie, great presentation, very informative.
Great.
And yeah, I will certainly be sending you that feedback from people that have just been popping comments in the chat. Yeah, some quick and easy, simple solutions that some less expensive, some more expensive, obviously, but you know, it can work across a number of budgets, I guess. Yeah, so thanks again, and thank you to everyone for joining in today. And yeah, for those of you that missed it, the link will be available fairly shortly. I'll be sending that out. Archie, if you have any, do you have any? I think you mentioned earlier that you had some website links, or did I misunderstand? I'm not sure.
Yeah, I can flick out some links as a follow-up to some of the products, like the seals from Efficiency Matrix and EcoMaster. Right. Happy to share those.
Okay, if you want to send that to me, and then I can send that out to everyone with the link, that'd be great. All right, on that note, thanks again, everyone, and thank you to Archie, and all the best with sealing up all the gaps in your home this winter, and stay warm.
That's it. Good luck, everyone. Thanks so much for tuning in, and thanks for having me. I hope it was informative.
Thanks again, Aki. Bye-bye. Take care, everyone.
Bye-bye.